Now, we've already looked at the centre of mass of a set of particles. We've already looked at the centre of mass of a lamina, a solid shape. And what we're looking at here is the centre of mass of a wire framework. So there's no material in the middle here, but these shapes here have mass. So here is a wire framework. And we need to find out the centre of mass of this framework. So it's very similar to the work we've done before. Imagine that as the x-axis, imagine this as the y-axis, and we need to find the centre of mass of each of the parts of the wire. So because the length from there to there is 4, we can say the mass is proportional to 4, and the centre of mass of this section of the wire is going to be here, and that's at 2, 0. So what about this one? Well, the length is 1, so the mass is going to be proportional to 1, and the centre of mass is 4 along and 0.5 up. What about DC? Well, the length there is 2, because that's 2, that's 4, so that length there is 2, so the mass is proportional to 2, and the centre of mass is going to be here, which is 3 along and 1 up. Now let's think about DE. The length is 5, so the mass is proportional to 5, and the centre of mass is going to be 2 along and 1 and 2.5, so that's 3.5, so it's 2 along and 3.5 up. 1 plus 2.5 is 3.5. Now we look at FE. The mass is proportional to 2, and the centre of mass is going to be at 1, 6. And now look at AF. The mass is proportional to 6, and the centre of mass is at 0, 3. So all of that equals the total of the lengths. 4 plus 1 is 5, 7, 12, 14, 20, so the mass is proportional to 20, and we call it x bar, y bar. So if we equate the x components, we get 20x bar is 8, 4 times 2 is 8, and 4 is 12, and 6 is 18, and 10 is 28, and 2 is 30, so that equals 30, so therefore x bar is at 1.5. And then let's equate the y components. So we've got 4 times 0 is 0, a half, 2 plus a half is 2.5, 5 times 3.5 is 17.5, so that's 20, 32, 40. So 20 y bar equals 40. Excuse me, so y bar is at 2. So the centre of mass is 2 units from AB and 1.5 units from AF. I introduced x and y, so I can't give it as a coordinate, it was this. So it's from AF, it's 1.5 along, that's the x number, and then from AB it's 2 up. Let's just check this makes sense. 1.5 and 2 is 1.5 is nearly there, nearly at 2, 2 is there, so the centre mass is about here. That seems about right. So there we go, that's how to find the centre of mass of a wire framework.